120 gram per capita per day. And then we calculated the specific energy consumption based on that. So let's look at some key figures. Energy check, or by conducting energy check, we look at this table. We look at this table, and we see that we divided the wastewater treatment plants in Jordan to 5 categories based on the population equivalent from plant size 1 to 5, and also the process type. We see that most of our wastewater treatment plants actually lie under plant size 4, and activated sludge system has like around 54 kilowatt hour per capita per year as a median value for the wastewater for the activated sludge system. If we look in more details, this is the chart showing all wastewater treatment plants, the 20 wastewater treatment plants, and the median value for all of them as 20 wastewater treatment plants. And we see that the treatment plants lying above this wastewater treatment, above this median value. This means that there is like a potential, or like there is a space to improve these treatment plants by applying some optimization measures. If we look at this graph, this is a graph from the DWA 2013. This is from the draft version showing the different classes, plant size of wastewater treatment plants in Germany. And we wanted to compare our key figures with the reference line, with the German standards, with the German benchmark. So we plotted our 20 wastewater treatment plants and compared it with the plant size 4 from the German side, and we see that we are far to the right, and the German actually far to the left. We have like around 50 kilowatt hour per capita per person, and in Germany they have 35 kilowatt per capita per person. So this means that we have still space where we can also applying optimization measures and improve our wastewater treatment plants. And this is also the only the activated sludge system alone. Then the number is actually increasing to 54 kilowatt hour per capita per person per year. So only the activated sludge system. I will run directly to the energy auditing. The energy auditing is a later process for the energy optimization. And it's an important step in that. And luckily, during this stage, we got a project from the Ministry of Environment from Germany. We had the project, we had like 3 case studies, Aqaba, Mu'ta, Mazar, and Assault treatment plants. And our aim was our aims were to identify the energy saving and energy reductions and reducing the energy consumption of wastewater treatment plants with our partners from P2 in Berlin and strategical partners from the Ministry of Water and Irrigation and Water Authority of Jordan. So I would just show a pie chart for, I mean, maybe it's not so clear. So it's a pie chart showing the energy analysis, and it shows like there is around 67% of the whole energy usage in the wastewater treatment plants actually used for the aeration tank. What we did as energy optimization approach in this project is that we have energy auditing and analysis for these treatment plants. And then we applied short-term optimization measures by steering and control the aeration system in Aqaba wastewater treatment plants. So for that reason, we installed controllers and oxygen sensors in the aeration tank in order to steer and control and reduce the energy consumption in the aeration tanks. How we would present our results? Let's say we will have benchmark, and we have the real status from the real value from the wastewater plants. This is the current status, let's say 2014. And we look at the reasons why there is like this high deviation. Then we specify the measures, and then we apply our optimization measures. And then after the realization, after the adapting of these optimization measures, in the future, the real value or the energy consumption will drop based on these optimization measures. As a modeling, then I have, I mean, there's like so many optimization approaches for the wastewater treatment plants. So there are a lot in the context of let's say process and the process in the context of instruments and so on. So what I want to do in the future as a further step is to have potential scenarios towards optimization, and I would like to test it using modeling. And for this stage, I'm going to use Simba model. It's a huge platform for different applications. And one of the application areas of this model, it's the one of the application is the energy consumption analysis of process of wastewater, sludge, and energy consumption. And in the model libraries, actually, it contains the activated sludge process as one of the different processes exist in the model libraries. And this is how it looks like, and this would be the further step towards optimization and testing different optimization measures, short-term and long-term measures. So at the end, to sum up, I would like to say that our fossil energy resources are really limited, and we have to look at this point. CO2 emissions have increased in the last 50 years around by 20%. And the cost of energy raised dramatically from 2014 to 2015. It's around, I think, from 0.084 fils to 0.094 fils increased from 1 year only. So more than 50% of the Jordan wastewater treatment plants are activated sludge system, and this number is increasing, so it means more energy consumption. Potential energy benchmark for Jordan is a necessity beside the Jordanian standard 893/2006. And in order to optimize the wastewater treatment plants, a main step is to have the treatment plants analyzed as energetically, to run an energy analysis for all wastewater treatment plants, for all the wastewater treatment plants in Jordan, and then see for each single case what would be the optimization measures for that. At the end, testing different potential optimization measures will be done also in the future step by modeling. But we have to be reminded at the end that wastewater treatment plants are designed to treat wastewater and not to look at the energy. It's a second stage. So the first thing is that wastewater is designed to treat wastewater. Thank you very much.
Thank you, Mr. Iyad. But I would like to say, maybe we started thinking in Jordan in wastewater sector or wastewater treatment plant about energy. Now maybe Mr. Malik can say that in the last treatment plant in Aqaba, we mentioned and we focusing for the contractor and the designer to focusing in energy improvement technologies he should apply and design regarding this issue. So thank you, Mr. Iyad. Now we will switch for another tools. Maybe it's not, we talk about automation and control, then we benchmark. Now we will talk about effective management, because if you have a control, if you have a benchmark without an effective utility management, maybe you will not reach your end with for energy efficiency. So let us welcome and present Dr. Amer Mokbel. Dr. Amer Mokbel have more than 20 years in a field of project operation and management in many areas in many countries. It's a lot of countries, I cannot say it here. And now he's joined since 2003 WILO as a director for Area Gulf. So welcome, Dr. Amer.
Yeah. Thank you very much, Mr. Yasser, for this nice present me. And I like to welcome you, very special welcome Mr. Malik and Mr. Awamle. It is for me very, very helpful, yeah? It's not, yeah? Okay. So thank you very much for your attending. That show me you are very interested in what WILO doing in your country. So, but this is not my presentation. Yeah, first of all, we speak always about energy saving, and we forget, we don't forget, but we should know water is life. وَجَعَلْنَا مِنَ الْمَاءِ كُلَّ شَيْءٍ حَيًّا. So water is more important as energy, but energy we need to secure the water. This is the let's say, exchange between water and energy. So therefore, energy saving is very important thing. And WILO, yep, just I forget one thing, so to present my colleague here, WILO is represented here in the Jordan with rep office. The office manager is Mr. Valmet El Kadsi, and we have our strong partner here in the country, Al-Arar Group, and I will come so Haitham Group. He is 24 hours able to catch him if you have any problem in pumps or water. So that is now to continue our topic. So why we, so how I show this? I am not so good in the technique. This is the full, this is the wrong, is this PowerPoint? Yes, yeah. So WILO select Jordan to make some example for energy saving. Why we select Jordan? Because if you can do it in Jordan under this condition, what is country have, I don't like to say challenge, problem, it's a big challenge, then we can do in every country. So therefore we select Jordan, this country with really have one of the worst country in the world, and the excellent minister told that in the opening ceremony, the high water scarcity in Jordan, also Khaldun Kashman mentioned this, in Jordan really is one of the biggest problem. The country faced high water losses, for more than 40%, this is in the top. The challenging in the topographic issues, 1,000 meter difference, high difference between the points. So, okay, there is also a lot of outdated pumping station with low energy efficiency exist. And we know 15% from the energy, because of this different high topography situation, that the 15% from energy, let's say, and consumption are going to using for the pump, to operate the pump. So, and then last but not least is the very limited financial, because financial resource, because the country is very limited in all other resources. So all these points give us to make our action in this country. We see this all problem what I mentioned before as opportunity, not as challenge, as opportunity. If we have really old pump, we can also change it with new pump, and we can save energy. We can then secure the issues. We have also a lot of very educated, good educated people. So if you train these people, you will have then good operator. So this is opportunity for us to secure the water supply, to optimize the maintenance, and to solve the problem. So what we started in Jordan, maybe Mr. Awamle can remember, 2003. And what we started? We started not direct with the technical. We said, okay, what, technology or training? So we started with the training because you need the people. If you have high technology and the people cannot operate this or have some problem, then after short time, your investment will be not effective. So then we started with the training. What we doing, sorry. So everybody knows in Al-Zreiqat is central workshop for repair the pump, and we heard, by the way, all our project what we're doing is partner project. It's not WILO alone. The first partner is the, let's say, Miyahuna Watch Ministry. Second partner is GWP as organizer for networking, German consulting, and Jordan. Second partner is a local partner, NGCOM, our local partner, and let's say another installer and so on in the country. We cannot do alone. We need a partner, and this is one of the results our activities here. So what we do, we heard there's a lot of file of the pump, and the normative using Dawa for the pump is only 2 years. We said this is not effective. We started, in cooperation also with GIZ, to let's say to make a plan for this workshop in Zreiqat, and our target was to draw up service working plans, to optimize the process, and to update the quality management system. And what was our action? We analyzed the existing situation. We trained the people in Jordan and in our company in Germany for servicing motor and hydraulic, and reorganized the spare part and the facility stock, for what you need for the repair the pump. And last but not least, we also optimize the test facility unit to test the pump after repair to find out is working or not. So this is the first. Then we go to the really project as pilot project on all way with very good supporting from Mr. Awamle. Yeah? And this project called Korea with existing situation was the pump efficiency was really less than 46%. We changed it with high pump efficiency with 70%, but what I like to say, not only change the pump is enough, you have to look all around the system. That means control panel, hydraulic part, that means the pressure, the pipe, the valves, and the pump. And also how you install the pump. So in section part, so all of them play a big role to increase the efficiency in the pumping station. So we changed it. Financing was around 300,000 euro. So the increasing efficiency was until more than 70%. And let's say we save, we were saving every year more than 120,000 euro. That means after 2 years, we cover the cost for the investment, and the third year was, let's say, more the wind for them. This is the first project, and then we continue this success. This, let's say I go faster because I have. The second project was a little bit more complicated. Is then the 2 pumping stations from Wala to Lib and from Lib to Madaba. Here we faced some challenge. We changed also the pump to more efficient pump, but we had maybe less attention in the system. And after, let's say, 1 year, we faced really big challenges in terms of water hammer, in terms of the electricity, and in terms of the system. So we do it then, let's say, in cooperation with NGCon, with ourselves, and with Dorsch Consult, with the local German consulting, to find out the reason for this failure. And we, let's say, we analyze the reason, we change it, we updated the system completely, we changed it also the pump, yeah, and at the end of the day, we have, maybe Mr. Awamle, you can help me, this is second year now, we have this operation, and every year, more or less, we can pump more than 7 million cubic. Yeah, about us. Until 12, we have the opportunity with the new pumps, so variable between 7 and 12 million cubic meter. So also the efficiency increased from 34 to 75. So that you can say, although we have the same effect now, like Up Korea, so we save, this is the more important thing, the result here. I will go direct to the result. Yes, that's what we do, I mentioned before.